So I'm Brecht van Kouwenberg. I am working at Altron, and I will present you today an implementation of our mesh protocol inside with our PicoTCP custom stack. So first of all, what will I talk about? Are three basic things. What are the possibilities with mesh networking? What is mesh networking? And what is our PicoTCP stack? And how does it work in general altogether? So mesh networking is actually a collection of different nodes which set up the routing information or the routing infrastructure to be able to communicate with each other in a dynamic way. So it will describe in a specific routing technique how they can communicate with each other. Where can it be used for? It could be used for sensor networks like geospatial information, different nodes that are spread over a geographical environment, or home automation, or actually have a network which is mobile, so like a MINET mobile network, which is configuring itself and dynamically adapting towards how the network is changing. So how does it work? There are basically two different ways you can implement a mesh network, and that's one on-demand or secondly table-driven. And the on-demand, an example of that could be AODV, which is a protocol that is describing that, and it's really asking the routing information the moment it needs to send some data towards another route. In contrary, the table-driven one will construct the routing information on the go and sequentially without having actually needing the data itself. So one of the table-driven ones is OLSR, which is the optimized link state routing protocol as described in RFC. And it will actually build the tables proactively before they will need to send data. So for example, this would be a routing table that is required for to get from one side to another. So if I would want to get to destination 3, then I want to hop through gateway 2, and it's going to be one hop, so the metric is going to be 1, and like that, it will build up all different routing information. Now, how does it functionally work? They will send, each node has the same intelligence inside, and they will send hello messages to all their neighbor nodes. All these neighbor nodes will connect to the other ones and actually select one of their neighbors as a multi-point relay, which is actually sending their topology information with TC messages to the rest of the network. Then there are two different more advanced message types, the mid messages, which will send more interface data towards the network, and the HNI to inject new routing information into from another network into this network. In contrary, the on-demand routing will be reactive and actually build the routes by a route request on the moment they require it. So what is the advantage of the one in contrary to the other one? If you have all the routes available, it will go faster to send your data, and you don't need to have the overhead of building up the tables. So and the reactive protocol will react more on different changes in the routing information. Okay. So how did we implement it? We made a PicoTCP stack, which is basically a networking stack built for to be a modular way to connect to other different devices without requiring a lot of operating system dependencies. So you can just run it bare metal and modularly select whether or not you want to have certain features available. So this is an example of how you could compile such an embedded stack. So you just select your architecture, your cross compiler, and the specific protocols we provide to have it compiled in your library. Okay, so if you want to check out this code, it's all publicly available on GitHub. You can just watch it at tasbelgium/github/Cotcp and ask any questions there if you would have them. The source is open and dual licensing policy, so you have the GPL version 2 and a proprietary one if you would like for more to have it for your company specifically, if you don't want to be stuck to the GPL parts. Okay, so how did we do our mesh implementation? We had a challenge to port it towards the University of Ghent network. They have a set of nodes that are connected to each other. 50 nodes, and we needed to port it to that network. And there was also already a TinyOS port available, so we made a port towards that, and thereby improve our OLSR support and prove the feasibility of this product. Okay, so the first step we did is actually port our stack to the TinyOS application and use the NASI wrapper to support the Cotcp API. I will give a short demo in the end of that. So what was this actually? So we have on the top an application which is actually using the libctcp to interact with the networking stack, and the networking stack also requires a small driver to send it to the physical device actually, and also next to that there's one shared library available which supports the timer functionality of both TinyOS and Cotcp application. So to have all that running, we just had the TinyOS with the application and the radio driver included, and then have IPv4, UDP, and ICMP for just to send some ping messages, and the OLSR which makes the mesh network develop available. So all that together was constructed in 27 kilobytes. So the code for this is also available on Cotcp, so you can check that out. So to facilitate the debugging, we used the Talos B boards. The network in the university is all built up by those boards. So we actually had one board which was connected to our PC for easy debugging, and there was the Talos B board, so the port for that is also available. Next to that, to separate it from the real world, we have written a mesh simulator where you can actually implement your own application and see how that goes. So you can visualize where your nodes are situated and see which routes are being built. Okay. So this is actually the implementation of the mesh network on the university. So we have about 50 nodes over here, which are all connecting to each other and having the same intelligence, just building up the routes inside, and that looks kind of like this. So you just begin to get a lot of nodes that are having routes towards all different nodes, and specifying their metric available on the right hand side. Okay, so I will give a short demo on how this OLSR is behaving in the mesh network on the university, and we'll give some description. Yeah, okay, I think it's 2 minutes, so it should be fitting in there. Yeah. Okay, so first of all nodes are booting up, and we'll try to send the hello messages as I have said. So you will see all green arrows connecting to the nodes which are actually next to each other. So I've made the delay pretty extensive, and you can actually set how fast you want the nodes to react on the specific targets. So normally it should be around here. Okay, so now you can see all nodes are connecting to their neighbors, and actually there are, with the S17, are the amount of nodes which are available in their routing table. So I made them become a different color once they become having more routes. So more and more all messages will send through the network and divide their routing information inside this network. So you can actually see that, for example, the orange arrows are actually 2 hops away, so you can send a message via another node to a 2 hop away node, and the red arrows are the 3 hops away. So you can actually see the longer the network is being configured, the more nodes can be accessed in the system. Okay. And so that's kind of how all routes are being built up, and in the end, when all routes are configured, it will be possible to plug out one node, and all network will adapt towards this. Okay. So I think that's the most important part of this. So that was a bit faster than predefined, but to come to the conclusion, we have ported successfully our application to TinyOS and provided an OLSR implementation of mesh networking. So all this is running on IEEE 802.50.4 network. So if you would like to have more information, I would advise to come to our stand, and I would be willing to answer your questions. Okay.
Okay, some final words. Thank you all for coming. Many of you have left already. I just want one thing to be sure: if you go out, just look around. If you see anything, then shoot the one in a dirt bin, take it with you, and clean the dirt bin outside, so we don't have to do it. Yeah, I mean, if you have questions for him, he will be around here or around his booth, so go ahead and talk
just
to
downstairs.
him. And I hope you enjoyed this FOSDEM Spatial Dev Room, and I hope we have another one next year. I think it was successful.